My name is Aditya Sherwood and I'm here to present my project Artificial Intelligence for Descriptive Paper Correction. Basically, it means to use artificial intelligence for descriptive paper correction. And we'll be looking at what artificial intelligence is and how my system works, what are the tools that I've used, and finally I'll show you a demo. So, artificial intelligence, to put it simply, is basically the ability of a computer to simulate intelligence through software or code. Next, how does my framework or my system that I've developed actually work? Well, first, the teacher uploads the student's answer in the form of a PDF or image to the system, which then runs it through a OCR or optical character recognition software, which basically does this. It takes in an image like this, then converts it into computer readable text, which you and I can edit. So an example would be like, say that I have an image like this, and if I run it through an OCR program like Google Docs, it basically takes all the text in this image, recognizes it, and puts it in a form that is editable. So for example, here it says optical character recognition, brackets also called as optical character reader, and it recognizes it, optical character recognition, also called as optical character reader, conversion of image typed, and so on and so forth, which I can actually edit. So after this step, what happens is that the system runs the resulting OCR through a spell checker to check for any spelling errors and correct it. Next comes the important step where the model actually computes an embedding. So what is an embedding? Well, embeddings are essentially a way for the computer to understand the semantic or the meaning of a word with relation to another word. And the values of an embedding ranges from 0 to 1. So basically, the similarity of the word from of good and bad is 0 to null, and the similarity of a word like good and great is 1 or 0.9, and so on. So using this embedding, we can compare the similarity or the similarity between the student's answer to the actual answer given by the teacher. So I'll show you an example of how this works too. So basically, I'm in this website called projector.tensorflow.org, and if I select a word like let's say diagrams, it gives me the similar words with their corresponding confidence score. So the model thinks that diagram is similar to equations, drawings, objects, and formulas, and so on, which is actually quite right. So by using this method, by using this embedding, we can actually compare the meaning of the student's answer to the meaning of the answer key and to compute the final score of the student. So for computing this embedding, I've used a software called DistillBERT. So BERT was actually a model developed by Google for natural language processing. And to compute these embeddings, the model or the software needs to know a variety of words. It needs to have a large lexicon or a dictionary so that it can correctly identify the meaning of each and every word, so that it can compare it with the actual answer given by this. So for that reason, I've used this model called DistillBERT, which is a variation of the BERT architecture or model. So then after doing all this, it finally computes the marks of this by using a method called the cosine score, which can be explained as, imagine these embedding sets vectors in space, like let's say that I have this vector. Let's say that this is the vector of the given student's answer, and this is the vector of the actual answer key. It basically checks the angle between this vector and this vector so that it can compare the similarity between the student's answer and the actual answer key. So this results in a value between 0 and 1, which after multiplying it by 100, we can represent it as a percentage. So that's how my model actually works. Now, what are the tools that I've used for this model? Well, for the actual OCR, for the recognition of the text in the image, I've used Google Drive's OCR API, which is Application Programming Interface. And for the actual model that I've specified is BERT, to perform the semantic meanings or the vectors or the embeddings, I've used the Hugging Face transformers. And then for the spell checking algorithm, I've used software called Spacey. Now, I'll show you the actual demo of this project. So this is the app or the website that I've developed for this project, which is artificial intelligence for descriptive paper correction, and it asks us to upload the student's answer, type in the answer key, input the student name and the year of study, and finally click calculate mark to show the marks. So if I upload this file over here, which is actually a dental graduate's paper, and this answer key over here, and let's type in the student's name as test for now, and then if I click calculate marks, it will actually calculate the marks. So I've inputted all the variables and it has outputted me the name of the student, year of study, and the mark too. So let's see how it actually does that. First, as I told you before, it calculates the answer for the given answer, which is the real answer, the actual answer, into an embeddings like this, which is basically the similarity of word to word. And then this is the cosine score for each and every word to the word from the actual answer. Finally, if we take the average of all these values, we would have the 86 over here. So, and I've uploaded the source code for my project in the website called GitHub, which you can check my code. So thank you for listening to my project. I hope it was nice. Thank you.